Welcome back. Let's do another problem. All right, so for this one, the setup is this. You want to travel from A to B. And the configuration looks like this. You've got some place A to B over here, and you've got some place B to be over here. And you know that on this route, you can travel at, what was the speed? 110 kilometers per hour, or whatever. And you want to go at an angle down to that road and then travel on the road. But as you're traveling here, imagine this is off-road, you can only travel at 60 kilometers per hour. And you want to know, the total distance from here to here will be 50 kilometers. And the question is, where do you pick this point? How far over do you pick this point to minimize time? All right. Okay. All right. So step one is to convert this problem into pure mathematics. So convert to math. Often this involves, labeling things so that you have variables to work with. And often it involves pictures, though manifestly this one already has a picture. So, here we go. Setup looks like this. You've got a triangle. Here's A, here's B, and we've got 2 points here. And the question is, how far over do you pick this point from the perpendicular? Is it perpendicular? I guess I didn't say that up here. So, it makes sense to label that X. And since the whole distance is 50, that means that this distance has to be 50 minus X. Okay? All right. We'll probably need to know the length of this, the hypotenuse of this triangle here. So Pythagoras tells us how to do it. Oh, I didn't tell you how far this was. This distance was 30. 30 kilometers. Now we can solve it. All right, so this distance is 30. So you know Pythagoras, x squared plus 30 squared is this unknown hypotenuse. So that tells you that that side is the square root of 30 squared plus x squared. All right, well, at least we have a very complete picture. But we really cared about not distances, but times. So remember, this road you could travel at 110 kilometers per hour. And this one you could travel at 60 kilometers per hour. Is that the right number? Yeah. All right. So we care about time. And remember, velocity is sort of change in distance over change in time. So if you wanted to know time, you could solve for t to get time is distance over velocity. Now in the picture we have all the distances labeled, and we know the velocity, so that means we can label the time. So the time to travel here in this picture the time that you're going to be traveling here will be the distance, so that's the square root of 30 squared plus x squared, all divided by the velocity, which was 60. And the time here will be the distance, so that's 50 minus x, all over the velocity, so that's 110. So the time the trip takes, I'm going to call it the function t, will be the square root of 30 squared plus x squared all over 60 plus 50 minus x all over 110. And we want to maximize, that's a lie, we want to minimize t. So that's the mathematical content, minimize that function. All right, if we're going to do that, we need to know the intervals. So step 2 on this would be to figure out what intervals we care about. So what can x be? So the smallest x can be in this picture is, you see 0, you go straight down. So remember x was here. So 0 has to be at least x, or the biggest x would be 50. That would be if we went in a straight line from A to B instead of straight down. All right, so that's the interval. So now we do the calculus. All right. So remember, we want to minimize the function t, which is this square root of 30 squared plus x squared all over 60 plus 50 minus x all over 110. And we want to do it on the interval 0 to 50. Okay. All right, old stuff now, just calculation. So we need the critical points, which means we have to solve 0 equal to t prime. And t prime, well, thinking of, again, that as 30 squared plus x squared to the 1/2. The derivative will be 1/2, and then we'll have the 60 in the denominator, and we'll get the square root of 30 squared plus x squared, then times the derivative of the inside, so that'll be 2x, so that's the derivative of the first term. And the derivative of the second term will be 0 minus 1 all over 110. All right, so the 2's will cancel here, and we end up with x all over 60 square root of 30 squared plus x squared minus 1 over 110. All right, well, we want to know when that is 0. So put the 110 on the other side. And then multiply by the denominator on the right side, so you get 60 30 squared plus x squared, and multiply by the denominator on the right side equals 110x. You got that pesky square root in there. Oh, let's divide both sides by 10 first of all. But to get rid of the square root now, let's square everything. So we get 6 squared 30 squared plus x squared equals 11 squared times x squared. So this side will be 6 squared times 30 squared plus 6 squared times x squared. Let's put the x's together. So we'll have 11 squared minus 6 squared x is equal to 6 squared times 30 squared. Let's see, that's 121 minus 36. I guess that's 85. So, blah, 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 x will be 6 squared times 30 squared all over 85. Take the square root of both sides. X equals 6 times 30 all over the square root of 85. That's something you can put on your calculator, and you get about 19.52. Now, there was a negative, also x could be negative that, but I'm not listing it because the negative numbers aren't in this interval. Okay? So the only critical point in the interval is that one. So, not hard, but, painful. Now we make a table, because we want to find the max. We put the critical points here and the endpoints. So the critical point was 19.52. There was only one. The endpoint was 0. The other endpoint was 50. And then you put in your function for time, which I've already forgotten because it was pretty ugly. All right, looks like this. X all over 60 square root of 30 squared plus x squared minus, oh boy. Oh, no, I wrote down the wrong one. It was that thing. All right, so it was, let's see if I have my paper here so I can copy it. The square root of 30 squared plus x squared all over 60 minus, or plus, 50 minus x all over 110. All right, so these are pretty ugly numbers. I would put them on your calculator, and that's what I did. And the answers I got was 0.87 here, 0.95 here, and 0.97 here. All right, this is the minimum. So the answer will be the minimum time is, if you check the units, it's hours, 0.87 hours. And you get this by taking x equal to 19.52. There you have it. All done. Ciao.